Hello, everyone. Good afternoon and good morning. My name is Liran. I am the COO of Seebo. Today, we are going to speak about process efficiency in cement manufacturing and introduce Seebo. In short, Seebo is a predictive quality and yield solution. At Seebo, we invented new technology. We call it process-based artificial intelligence. We actually built algorithms that understand cement manufacturing. An algorithm is a mathematical equation, and usually mathematical equations do not understand cement manufacturing. Embedding the knowledge of clinker making and cement making into an algorithm is an ultra complex task. And around that, we built an entire solution for the cement industry. The ultimate goal of the solution is to enable your teams in your plants to predict and prevent losses that are related to quality, throughput, emission, and energy. And there is a big emphasis here on your teams. Building good algorithms for the cement industry is a big challenge, but making it accessible for the everyday people and for them under the stress environment and the tasks they need to do to get the relevant insight in order to optimize the production, it's even a more complex task that Seebo took on itself. When we look at clinker making and cement manufacturing, we are looking at increasing the throughput, increasing the alternative fuel rates, emission reduction from CO to NOx to SOx, optimization of the clinker quality, reduction of cost per ton, and obviously the energy consumption, especially now with the energy crisis in Europe. We are seeing a very high electricity pricing and optimizing the process to optimize that as well. What's common about all of those challenges is that those are all process inefficiencies. And when your teams on the ground are looking at process inefficiencies, they generally ask themselves the three most important questions. Why inefficiencies are happening, how to prevent the inefficiencies, and when is the right time to act. The Seebo solution performs automated root cause analysis. We highlight automatically the primary suspects of the losses. And this is something that we do for the entire process. And this is one of the unique points in Seebo. We look at your raw materials. We look at your alternative fuels and fuel characteristics. We look at the kiln process, cement mill, and down to 28-day strength. By overseeing the entire process, the algorithm can explain why different challenges are happening. Then, using predictive recommendations, the solution is recommending an operational envelope. The solution is identifying a set of process parameters and process values, and it recommends on which values you should stay in order to get the most out of your fuels and raw materials. And eventually, using proactive alerts, your team knows when to act. So when your process is slightly going out of the envelope, there is a mechanism that helps you to go back into the envelope. That leads all together to continuous process mastership using artificial intelligence. Few words about Seebo. We are recognized by Gartner as a cool vendor in the artificial intelligence space in manufacturing. We have co-sell strategic partnership with Microsoft and recently nominated by the World Economic Forum as a technology pioneer. Seebo raised to date $46 million, and the press in the cement industry is quite excited about it. The reason is that there is no one else investing so much money in building algorithms for optimizing the cement and clinker manufacturing process. At Seebo, we are not only mathematicians, we are also cement experts. Ken is leading the expertise with more than 130 optimization projects around the world and many years of experience. To the people in the audience that would be interested, I'll be happy to share after the call. Simply contact me and I'll be happy to share after the call the webinar and the interview that we did with Emilio, the head of Group R&D at Holcim, and their story and tremendous achievement in the work with artificial intelligence in the manufacturing side. Similar situation with Marcus, the technical director of CRH. and the beautiful achievement that they are doing and achieving with working better with data. Many people that we meet would ask, okay, guys, there is an expert system and a closed loop control for many years in the market. What is the difference between a Seebo and an expert system? So there are a few key differences. First difference is the one that I mentioned earlier. A closed loop control is looking on a siloed area. An expert system would operate the kiln, would operate the raw mill or the cement mill, while Seebo is overlooking the entire process. The second major differentiator is the fact that Seebo is a decision support tool. We actually work with your operators and process experts in real time and help them to take process-related decisions quickly and accurately. Almost all plants in the cement and clinker industry today are heavily dependent on human decision-making. And let me show you. Everyone at the end of the day are interested in efficient production process. For that, companies generally do two things: deploy an expert system or an advanced process control, and have humans overlooking the entire process, since the expert system is overlooking only a specific part of the process. And when you deploy an expert system, you have a research that humans are performing to find the logic and to see how it affects the closed loop control. And also, when you maintain the expert system, humans are updating the logic. So technically, all the process-related decisions in the plant are done by humans. Now, let's take a quick look on how humans are getting a process-related decision. So if I'm working in your plant as a process expert, I will have hundreds or thousands of data tags from process, raw material, quality, fuels. And since I am simply not capable on analyzing them all, I will choose a few based on my knowledge and my experience as an expert. I would run a few mathematical equations on those selected tags, and based on my calculation, I will prioritize and conclude. So this is a good journey. This has actually led many plants to good optimization, but this journey has a glass ceiling, and it's due to the challenge in the early part of the analysis. The analysis is based on human experience and human knowledge. You are guesstimating when you choose the tags. You are simply not analyzing the entire data set, and you are missing relationships and important insights. So the work that humans are doing today, the data analysis is done on a few selected tags, and it's human dependent. Different humans will get different results. It's an assumption validation only. It happens ad hoc only when we do it, and it's siloed. It's on a specific set of tags. So we understand the challenge. It's assumption validation only, ad hoc, not scalable, and siloed. While when we speak with different process experts and different executives and operators from the field, they would look for something completely else. They would look for a meaningful insight that is generated continuously. At every given moment, we would like to understand what is impacting our KPIs. We want something that is ready to scale, so once it works, we want it on many different kilns. Ready to use, so we don't need to work too hard before our operators and process expert can use it, and it's overlooking the entire process. So now when we understand the challenge, when we know that the processes or the plants are heavily dependent on humans, and humans has naturally a glass ceiling in terms of the analysis ability, this is exactly where Seebo comes into the game. We built an artificial intelligence solution that is overlooking the entire process and sits next to your experts and help them to move from a manual siloed operation to an automated analysis on the entire process. So let's see how we approach the challenge. So obviously the plant has different data sources: the process, raw material, quality, and alternative fuels, weather around the plant. Once we have access to the data, we will aggregate it into one multi-source schema. One of the challenges that almost every plant has is the fact that the data is split in isolated islands, and connecting the data in the right way is a complex task. So we built a lot of intellectual property and automation around aggregating manufacturing data into a single multi-source schema. And then we do something that no one else does. We build a digital model of your unique and specific process. And using the intellectual property and tools that we develop, we enrich the algorithm with the process knowledge. So right now, the algorithm is no longer looking only at your data, but it looks at the data with the context of the process. So the algorithm can do a whole world of new calculations that traditional algorithms cannot. And I'll give you just one example: dynamic traceability. Imagine that I'm going to your plant and I'm holding a clinker. And let's say that the quality of this clinker is not as good as you wanted it to be. In order to understand why it happens, we need to calculate the traceability of this specific clinker. We need to know what raw material was involved, what alternative fuels were exactly in the production time. We need to know what was the temperature in the kiln and what was the temperature in the cooling tunnel, and so on and so on. Only by calculating traceability accurately, we can connect this data to the specific clinker. Now, since this is really complex, we wrap it up with a simple, easy-to-use user interface that is designed for your day-to-day teams to use. If you are interested to see a full demo of the Seebo solution, please contact us. I'll be happy to jump on a call and show you the actual solution. Now let's take a high-level overview of what the solution is capable of. Starting with the automated root cause analysis. So here we see that we are optimizing, in this case, a kill amp optimization target. And within the kill amp optimization target, we can directly go to the automated root cause analysis. The plant has different optimization goals: increasing the alternative fuel rates, increasing the throughput, or reducing CO2 emission. Each one of those problems will get a problem card. And once we go to the automated root cause analysis, the algorithm is taking data from alternative fuels, from raw material, and from process, and is coming back to you, the manufacturer, automatically, explaining what is the most important contributor for the noises in the kill amps, the ones that will affect electricity, fuel consumption, quality, and many, many others. So here we see that this is the cyclone temperature. This is the bottom cyclone, cyclone number 4. This is the most important contributor for the kill amp optimization. I'm curious about that, so I would click here, and I would find the values that contribute to inefficiencies versus the values that contribute to stable production. So as a process expert, from one hand, I'm very much excited. This is important knowledge about my plant. But from the other hand, I'm concerned, and I have two good reasons to be concerned. The first reason that I'm concerned of is the fact that maybe I'm going to optimize the kill amps, but maybe I'm going to give up other KPIs on the account of this KPI. I'm actually not looking for a specific local optimization, but I'm looking for a global optimization. I'm not looking to optimize one KPI, I'm looking to optimize my entire set of KPIs. The other concern that I have is the relationship between the different tags. If I'm changing something here, should I do any other changes in the manufacturing process? Exactly to address that, we introduce the multi-problem analysis. This is a set of tools that will help us to identify what are the right parameters, not for a specific problem, but for a set of problems, and to find the common ground in terms of process efficiency. Then, using the multi-tag analysis, you can identify a relationship between tags and find an operational envelope. Find a list of, let's say, 10 or 20 data tags and their values that you need to maintain in order to be most efficient. And eventually, using proactive alerts, the team knows how to stay within this envelope. So a quick summary. Using the Seebo solution, your process experts know why inefficiencies are happening and how to prevent them, and the production team knows when to act. That leads altogether to the ability of your teams to predict and prevent losses that are related to quality, throughput, emission, and energy. I would like to thank you for taking the time to watch the quick presentation, and it's a great moment to answer questions and feedback. All right, so there is a question that speaks about the amount of data that is required for the analysis. The question goes like that. You mentioned Holcim and Heidelberg, who have been using TIS for decades. Does a company with a long history of recording and archiving TIS data have big advantage in implementing Seebo AI? So the short answer is yes, we need data, but it doesn't have to be for a very long time. Usually 6 months of good data from the plant would be strong enough and good enough for the analysis. All right, question 2 from Ian Relly. What do you see as the key barrier to adoption for companies that have not yet used this kind of approach? So I would like to speak about 2 kinds of barriers. One is the mental and the other one is the physical. So in terms of mental barrier, it's new, it's innovative. We did not do it yet. Is it the right thing to do? Are we ready to approach something like that? Are we ready in terms of change management? Will our operators adopt that? So by addressing, to address this kind of challenge, I would recommend the lighthouse strategy. So choose a production line or a kiln or a cement clinker manufacturing process that has those team members that are hungry, that are looking forward to do the next thing, that would be excited from bringing the latest technology. Create with them a win case, and that it will spread around the company. We've seen that many times. So I mentioned the mental barrier. Now let's speak about the physical barrier. Sometimes data is not good enough. In many plants, we see, for example, that alternative fuel data should be better in order to understand the effect of alternative fuel on the quality or on blockages in the cyclone and so on. So it's very important to do a proper assessment for the data, to map if there are missing data sources, and if there are, to bring them as part of the deployment journey. Question 3 from Thomas Fabian. What type of AI is behind? So AI is a complex and big world, and there are many different buzzwords. So I can, if I move to a little bit more mathematical professional language, at Seebo we are using supervised learning. Supervised learning is the right approach for a problem that is happening many times, has high frequency, and we are looking to understand the pattern of the problem. And on top of the supervised learning, we invested, as I mentioned earlier, almost $50 million in building algorithms that are designed for continuous manufacturing and the cement industry. So in terms of type, the basic type is supervised learning, but when you go a little bit deeper, you realize that it's a lot of intellectual property that was built specifically by Seebo. Question number 4 from Muhammad. Do you have any case study from process optimization? Definitely, we do have case study that we are happy to share. Muhammad, in a moment, I will share the screen. Maybe I will do it now with my email address. You or anyone else from the audience is more than welcome to contact me over this email. I'm happy to schedule a call and share from case studies to recommendations and experience. Okay, let's see the next question. In your perspective, how do you define valuable usable data to apply Seebo AI in a facility? So I think it's an excellent question, and there is no single answer here. The right answer depends on the business goal. So I'd like to introduce two ways that usually people answering this question. One way is let's collect data for the sake of collecting data, and let's work hard just to make sure that we don't have holes in the data and that we have the data in the right frequency. And those projects could be really expensive and really long, simply because of the fact that you are collecting data just for the sake of collecting data. While the other approach is the approach that we recommend, is collect data to solve a problem. And for that, you need to define a problem. So if we go back to the question, your question, I would ask you, what is the challenge that you would like to tackle? Is it emission? Is it quality? Is it cost per ton? Is it throughput? Now, once we identify the right goals that you have, based on that, at Seebo, we have predefined list of data that is recommended for every business goal. We will work with you to make sure that you have the right data. And then when we get the data, we run statistical analysis on the data just to make sure that it has the right frequency, that there are no major gaps or holes in the data. And once we know that, we understand that the solution is ready for deployment. So the short answer, the right data is very much dependent on the business goal that you would like to achieve. Question number 6 from Delhi. Do you use a method for validation of the results? Yes, another super interesting topic. Almost every manufacturer that you are going to ask if they do have a proper definition of the goal, intuitively they would say yes. But when you actually dive into the deep definition of what is the right quality, what is the target throughput, what is the relationship between, for example, energy and quality and so on, you discover that this is a bit of more of a complex world. In cement, we have different goals that in many cases are contradicting each other. For example, I can produce really good clinker if I let go throughput and I increase energy, but this is not the case. I want to have a profitable plant, and I want to have the right quality, the right throughput, the right energy, and the right emission. So the first thing that, in order to answer the question of how do you validate results, the first and most important thing to do is to define what is the optimization goal. And it's a work that has to be done. It's a journey. Sometimes it takes weeks to have the right definition. Once you have the right definition, you did most of the way. You simply have a graph, ideally one simple graph that defines what definition is, a graph that takes into consideration quality, emission, throughput, energy, and so on. And you measure if this graph is going up or down, and you actually follow after the graph to see the results. All right, so those are all the questions. I appreciate the time from the team and from the audience. I'm sharing the screen again. Please feel free to drop me an email. This is my email address, and I'll be happy to have a deeper chat on your journey and see how Seebo can help you reduce different losses.